Hello and welcome. In this video, I'm going to discuss how to program the EdSim51 LCD display module. I will be using the source code given in the EdSim51 website as a base. However, I will make changes to the source code. Okay, so we will start by looking at the physical LCD module, which is the Hitachi HD44780U LCD module. The reason for looking at this particular LCD module is because the EdSim51 LCD module is based on this particular device. Okay, so here's a picture of the HD44780U LCD module. On the top left corner here are the 16 pins or 16 connections. So let me zoom in. Here it is. Okay, so this is the pinout diagram of the LCD module. So this is pin 1, and that's BSS ground. VDD pin 2, that's plus volts. VE for contrast voltage. I don't understand why this is labeled on the module as V0 or VO. I think we'll leave it aside, but on most literature, this is a VE or contrast voltage. Then pin 4 is register select RS. And then this is the read-write pin 5. And this is pin 6, enable pin E. And then from pin 7 to all the way down to pin 14, that would be DB0, DB1, DB2, and all the way to DB7. And 15 is the backlight for anode, that's plus volts. And pin 16, backlight cathode, and that's ground. Okay, next up, let's look at the EdSim51 LCD module schematic. This is the schematic for the LCD module. I've taken it from the EdSim51 official website. You can check it out at this link shown below here. I'm also going to put this link at the bottom of this video. You can check it out. I would like to remove the LEDs and the DAC so that we can take a closer look at the connections from the EdSim51 to the LCD module. And so we have here with the LEDs and DAC removed. The only thing for me to say is the all the data lines from the LCD module is connected to port 1, and the other thing to take note is the RS and enable pin on the LCD module is connected to also connected to port 1. RS signal is connected to P1.3, which is this one here, and the enable E is connected to P1.2. To really understand how this module works, I would strongly recommend that you download a copy of the HD44780U datasheet. The link to this datasheet is given in the EdSim51 website. Please check it out and download a copy of it. I will be, during the course of this video, referring to parts of the datasheet. Okay, and here is the block diagram of the LCD module. I'd like to highlight a few things from this block diagram. The first thing is when register select or RS, which is this pin here, when we set RS equals 0, then the instruction register or IR would be selected. And the purpose of the instruction register is to store instruction codes. And if RS is equals to 1, then the data register will be selected. And this register deals with the data that you wish to display on the module. And the next thing I want to highlight is the busy flag, BF, and finally the address counter, AC. Okay, at this point of the video, I'm going to look at programming the LCD module. As I mentioned at the beginning of the video, I'm going to use the original code from the EdSim51 website. Here's the link to the original code. I will also include this link at the bottom of the video. Let's take a quick look at the original code. Okay, so here is the original source code, which I'm going to use it as the base of my version of the code that I'm going to run. I am looking at the source code using Notepad++. Notepad++ is basically a text editor and also a source code editor. You may wish to download it. It is free. I find it very useful, especially in displaying long source code. Okay, let's get back to the original source code. So in the original source code, the characters that has to be displayed onto the module, LCD module, is defined here, and they are stored in these locations. 0 here is an end marker. Okay, so and there are several parts like function set, entry mode set, the display on-off control, and the send data part here, and the send character is also defined here, and the delay. What I would do is, for my version of the source code, I'm going to define all these set, for example, the function set as a subroutine. So that's what I would do for my version of the source code. Okay, so this is my version of the code, which is based on the original code featured in the EdSim51 website. Basically, I have divided my code or program into two parts. The first part is what I call the main, which is shown here, and the second part basically contains all the subroutine that I use in my main program. Okay, let's start off with the main. As usual, I'm starting my program at 0000 hexa, and I have defined the label RS, assigned it to P1.3, because that's where the register select is connected. RS stands for register select. E is for enable, that is equate or assign to P1.2. Now the read-write line is hardwired to ground to 0 volts. Now let's go to the main part of the program. So the first instruction here is to clear RS, which means RS equals 0, and that will select the instruction register. Right, the function of the instruction register is basically to store the instruction codes, and then it will call the function set, followed by a call to the display control, and then call the entry mode. And here it will set RS to 1. That will select the data register, and the purpose of the data register is to allow the user to send data to the data register to be displayed. And this part of the code, basically I am going to display only one single character. In this case, it's an uppercase A. Copy this into register A, and then call the subroutine send char. This subroutine will then display this uppercase A onto the LCD module. And finally, it finishes the programs, ends here and stays here. And that basically covers the main part of the program. Now let's look at the various subroutines. So the first one that we're going to look at is what we call the function set. And here I have extracted the function set and the instruction codes. So here is the instruction code for the function set. I'm only interested in this part, so I'll cover this too, the RS and read-write signal, so cover it up. Now, the LCD module in the EdSim51 is a simulation of the Hitachi HD 44780, and is connected to the 8051 in the 4-bit mode, for 4-bit mode operation. Now on powering up, the LCD module will go into an 8-bit mode. That's by default. And so the user would have to program the module to operate in a 4-bit mode, because the EdSim51 is connected in such a way that the LCD module operates in 4-bit mode. So the function set will assist us in doing that. So because we are operating in 4-bit mode, we need to send the data or instructions in 2 4-bit nibble. So with the high bit nibble will settle this instruction here, and the low nibble will settle this, will take care of this these parameters here. So let's focus on the last 4 bits, because that's the 4-bit mode operation, right? So again, we'll cover this up here. So the high nibble, because this is a function set, db5 has to set to a 1, right? So 1.5 will be set to 1, and the other 3 parameters, dl, n, and f. First of all, let's take care of dl. So we set that to a 0. dl is equal 0. That puts the LCD module into a 4-bit mode. So this, by sending the high nibble, this will set this to now to a 4-bit mode. Now we then need to send the low nibble which will take care of the N and F. So we send the low nibble out, and N is equals to 1. So that will give us a 2 lines display. And since F is 0, the font is set to a 5 by 8 dots. So now the function set is complete. The pause and delay explanation will come in a moment. So let's turn attention to the display control subroutine. Here I've repeated the, I extracted the instruction code from the datasheet. Again, I'll cover this up, and then we look at the high nibble and the low nibble, bearing in mind we're now operating in 4-bit mode. So we will focus on this 4 bits. We cover this 2 bits up, and then we look at the high bit is easy. It's all of them are 0. All the bits are 0. So yeah, so high nibble is all 0. So it's all taken care by these instructions here. Now, the low nibble this bit position here has to be set to a 1 because we are working on the display control. So by default, this has to be set to a 1. D, C, and B are the parameters. So D would be setting the entire display on or off. C will turn the cursor on or off, and B will set the cursor to be blinking or not. So we're setting everything to 1. So with the low nibble, everything is set to 1. The entire display is on, the cursor is on, and the cursor would be blinking. Let's move on. Now we come to the entry mode set. Again, I've extracted the entry mode set instruction code. Here we cover these 2 up. So this is the high nibble, the low nibble, the high. Then let's look at the 4 bits, cover this up. Then we send the high nibble out. That's easy, everything is 0 here. The low nibble DB, this bit position has to be a 1. And this time for the entry mode, we only had 2 parameters, and we are only concerned with the I/D. So we need to set this to 1, okay? And the I/D to set it to a 1. Now that would increment the display data RAM or DD-RAM address by 1, and the cursor will be shifted right when incremented by 1. So this bit here will take care of this too. And we are setting S to 0. All right, we're setting S to 0 because if you set S equals to 1, it will shift the entire display, and we don't want that. So we set it to 0. And okay, I mentioned earlier, I will explain the pulse subroutine. This is fairly straightforward. As a reminder, the E or enable pin on the LCD module is connected to P1.2, which is this pin here. And P1.2 is a negative edge trigger or falling edge trigger, which means this is the rising edge or positive edge, and this is the negative edge, the falling part. All right, so the P1.2 is a negative edge trigger. What that means is when you send this pulse up, basically we're setting set E, that will set it to a 1, and when we clear E, it will pull it down to 0. That means you go this way, falling. So this will generate the pulse. And what does that mean? When the input receive a falling edge, which is this portion here, the LCD module will read data lines D4 to D7 on the falling edge of the signal. So when it goes down from high to low, the module will read the data. And here is the send char subroutine. Since the EdSim51 and LCD module is wired for 4-bit mode operation, and so we need to send the data that is in the accumulator, that is the character to be displayed. We're going to split it into 2 4-bit nibble, A4 to A7 and A.0 to A.3. So we need to split it up like this, and we need to send each bit one at a time. So let's take a look at this portion here. So this is the high nibble set. Let's take a look at these two instruction here. This is the accumulator bit 7, so it's ACC.7. You have to write it this way, if not it would generate an error. So it's ACC.7. ACC here stands for the accumulator or register A. .7, copy that bit into the carry bit of the EdSim51. So basically this is a bitwise operation. And then from carry bit, we copy it to P1.7. Again, this is another carry bit operation. So now we would have copied the ACC.7 now to P1.7. Let's take a look at the next one. And here we are copying ACC.6 to the carry bit, and from the carry bit we copy it to P1.6. So this one here will take care of the high nibble set, and this one here will take care of the low nibble set. And then finally, the final subroutine that I want to show you is the delay. It's a very simple single loop delay. We load decimal 50 to R0, decrement it, and if it's not 0, we keep decremented until it's done. So a very short delay. And basically, that's all for the subroutines. Okay, so I'm using the Notepad++ to show you the entire source code. Not going to say much, but just want to let you see what the source code look like in its complete form, rather in different parts. So here is the code. This is the main portion of my code here, and the subroutines, they start here. From this point, this is the function set and the display control, the entry mode set, the pulse, and the send char subroutine, and finally the delay. Okay, so we are back in the EdSim51 simulator. So let me load the source code, assemble it. We have no errors. I'll run it, and there we have. the character A, uppercase A, is displayed here. If you want to see this thing, the cursor blink, I recommend the update frequency. You use the update frequency of 50,000. You can try a slower one, like 10,000, and you will see that the blink rate is a little slow. Okay, so let's look at how to display a simple message on the LCD module. And here's I've repeated the main program with a revision to how the message is being displayed. So the rest of the main program stays the same. So clear RS, call function set, display control, entry mode, set it to set RS to 1 to select the data register. And then when you come to this point here, what I've done is I define a lookup table. I've extracted the lookup table, which is supposed to come on later on, but I'll put it here for explanation purposes. So define a lookup table starting at 0200 hexa, and the lookup table basically consists of a string of characters. As you can see, it says hello world. So load LUT, which is effectively 0200 hexa, copy that into the data pointer register DPTR, and then clear the register. When you come to this point here, it has to work out the effective address. Basically, that's the contents of DPTR plus the contents of A. A is 0, so plus 0200 hexa. Basically, that goes here, which is this uppercase H. Copy that into A. Ask the question, is A 0? It's not 0. Call the send char routine to display the uppercase H to the LCD module. Increment the pointer DPTR to point to the next character, which is this one here. Jump back, clear A, work out the effective address, which is basically the contents of DPTR, which is 0201, because it was incremented here, plus the contents of A, which is 0, so the effective address is 0201 hexa. So go to that location, copy this character, which is a small case E, copy that into A, ask the question, is A 0? It's not 0, then call the send char routine to display the small e onto the LCD module, and increment the pointer to point to the next character, jump back, clear it, clear A, and then start and carry on. Eventually, it will get to this point where it will read the 0, which is an end marker, reads that, copy that into A. When it asks the question, is it 0? Is 0, then jump to this point where the program ends and stays here. So that's all for the main. The rest of the subroutines are basically the same, except I need to show you the lookup table, which I've done so earlier during the explanation. So at 0200 hexa, define the table, which is a string of characters. Let's look at the complete code now. Okay, so here's the complete code or program in Notepad++. So as you see, basically the program is the same as the previous one. Like I said in my explanation earlier, this is the part that I have made revision so that it can display a simple message. So the rest, just want to show you the rest of the program. Basically the same. Function set is here. The display control routine, subroutine is here. Then followed by the entry mode set, the post subroutine, the send char subroutine, the delay subroutine, and finally the lookup table here. Okay, so we're back in the EdSim51. I have uploaded the code to display the simple message on the LCD module. So let me assemble it. There are no errors, so I'll run it. This time I'm using the update frequency of 10,000. So keep an eye on this LCD module. Here you are, hello world, and it's the cursor is blinking here. Okay, so that's it for now. Okay, so that's it for this video. Thank you for watching, and the code that I've used in this video is given in the link below this video. Okay, see you in the next video. Bye.